All right, finding sine, cosine, and tangent of an angle in a right triangle. Now, let me just real quick give you a quick talk about trigonometry. The word trigonometry is the mathematical study of triangles. That's what trigonometry is. And there's all kinds of stuff you can do with triangles. It's great, great stuff. But the main thing that I want to get across to you right this second, right in this area of the book, is right triangle trigonometry. And right triangle will be required, okay, as you get to bigger and better courses such as trigonometry next year, or this year for some of us. You don't have to always have a right triangle. You can do some trigonometry with non-right triangles, and there's laws and rules that you can use to do that. For this class only, all I want to do with trigonometry is teach you the basics of it. I want you to just understand what sine, cosine, and tangent mean, and I want you to know how to use them in a right triangle. All right, so they're going to always specify an angle in a triangle. All right, and looking at a right triangle, here's a right triangle, there's angle A, there's angle B. Okay, one of the acute angles is what's going to be specified. So a right triangle always has a right angle, and it has two acute angles. Either one acute angle or the other acute angle is being used. Okay? For the specified angle, determine which sides are opposite, adjacent, and hypotenuse. And I want you to get accustomed to these three words: opposite, adjacent, hypotenuse. And I want you to know how to find each of those and how to identify each of those. So let me show you that real quick before we go on to what sine, cosine, and tangent are. I'm going to go 2 pages here. So, whatever acute angle I'm working with, in this case this one, okay? The opposite side is across the triangle from that angle. So that's pretty, I think everybody understands the word opposite for the most part, to go across. So if I go across the triangle, the side that I hit is the opposite side. And let me use the word opposite again to describe hypotenuse. The hypotenuse is opposite the right angle, always. So if this is the right angle, I go opposite the right angle, that's the hypotenuse. Okay. Now listen to the description of the adjacent side. The adjacent side is the side that is not the hypotenuse that creates the angle you're interested in. That's the description of it. It's the side that's not the hypotenuse that helps create the angle you care about. That's the adjacent side. If I've already identified the opposite hypotenuse, the adjacent side is the other one. That's the other description. All right? So do you want to go with the other one? Or it's the side that's not the hypotenuse that helps create the acute angle you're dealing with. All right? So once you've identified these two pieces, go across from the angle you care about, go across from the right angle, those are the opposite hypotenuse, the other side is the adjacent. That's the easier description of it. Same thing here, if this angle B is what we're working with, if I go across the triangle I get opposite, if I go across the triangle from the right angle I get hypotenuse, so the other side, the third side, is the adjacent. Okay? Those three sides being identified correctly are going to establish what the sine, cosine, and tangent are for a given right triangle. So this is not using a calculator, this is using your eyes and right triangle trigonometry to establish sine, cosine, and tangent values. So I'll go back to this page here. Sine of any angle is defined as the opposite over the hypotenuse. Cosine is adjacent over hypotenuse, tangent's opposite over adjacent. It's always a ratio of two of the three sides, and that's what sine, cosine, and tangent are and always will be in a right triangle. You have an acute angle. If you have an opposite here, hypotenuse here, the sine is opposite over hypotenuse. Opposite over adjacent is tangent. Adjacent over hypotenuse is cosine. All right? As far as mnemonic device is concerned, I don't know if you've heard this word before, mnemonic. A mnemonic device is an acronym or some sort of a shortcut you can use to remember something. All right? I'll give you one that you've heard of before. Parentheses, exponents, multiply, divide, add, subtract, PEMDAS. It's also, please excuse my dear Aunt Sally. Some people have that one to memorize the order of operations. That's the mnemonic device. Okay? Your teachers have been putting these things in your head forever. All right? But they didn't call them what they were. That's what they are. Ways to remember things. Anybody know the colors rainbow? I don't. Let's figure out Roy G. Biv. And all of a sudden we know them. Red, orange, yellow, green, blue, indigo, violet. Right? So that's a mnemonic device. It's a way to memorize something that's trivial knowledge usually, but it's something you wouldn't memorize easily, but with that it's real simple. Okay? There's two mnemonic devices for these. The one I use, the one I prefer is SOHCAHTOA. The problem with SOHCAHTOA is you have to know how to spell it. But if you use it enough, you know how to spell it pretty easily. What I do is I recommend every time you use it, you write it down until you get to the point where you don't have to look it up anymore. So you have to look it up to see how to spell it, but eventually you get to the point where you don't. Every calculator that I've ever seen in my life has sine, cosine, tangent in that order. Right there. Some of the, there's one that I think you hit a trig button that brings them up. They still go in the order sine, cosine, tangent. But anyway, but the buttons are there in that order. So S, C, and T are easy enough, but it's OH, AH, TOA. So sine opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent. That's all it is. That same thing. The abbreviations of each letter tell you about adjacent and opposite hypotenuse. The other one is Oscar had a hold on Arthur. Again, sine first, cosine second, tangent third, OH, AH, OA. Alright, so they're right there, whichever one you prefer. Again, I like SOHCAHTOA. I've been doing trigonometry since 11th grade, I think. 10th grade, somewhere in there. So when we did trigonometry at my school. Our teacher did SOHCAHTOA. I learned this Oscar had a hold on Arthur with this new book we got here. So anyway, so I'm accustomed to SOHCAHTOA. Use whichever one you like. Just know what they are. So, if I've got a problem of this variety, find the sine of A. Okay, this is what we're supposed to do. Now, A is some angle I don't know, right? And A is obviously right here. So if I see a problem like this on your homework, what I'm expecting to see on your paper is this. I expect to see a picture of the triangle drawn with A marked and the right angle marked. I expect to see the opposite side, the hypotenuse, and the adjacent side identified. Like so. I would recommend write down SOHCAHTOA on your paper. Every single time you have to use it, you write it down. Eventually the spelling is pretty straightforward. Alright? And then it says to find the sine of A. So which one of these do we need?
First one.
Need so, right? Alright, so is the one I need. Now, I've seen people do this improperly, so be careful about this. I'm going to write sine of A equals. I've seen people write so of A. Right? So is just the mnemonic device. Sine is the actual trig function, right? Sine of A. Okay? And sine of A is equal to the opposite over the hypotenuse, right? Opposite here is 4, hypotenuse is 7. And there's my answer. Okay?
Wow.
Does anybody have any reason why that might be helpful to us? Anybody know how big angle A is? Above your sine button on your calculator is a sine -1 button. That's the inverse sine button. Alright? If I know what the sine value is, and I use my inverse sine button, sine -1, and I type in my sine value, my calculator is going to spit out the angle that made that happen. So angle A is 34.8499 degrees. That's why trigonometry is useful in that sense. So the answer is this. This is the answer to the problem they asked me to do. It said find sine of A. But again, that's its purpose. If you know all sides of a right triangle, you have the ability to find all the angles of a right triangle. And guess what we're going to do in chapter 45? We're going to be finding all the angles of a right triangle, or find all the sides. So we're going to be applying it that way. That's where we're going with this. But for tonight's lesson, that's nice to know. But that's what they asked me to do. Find sine. But again, in a couple lessons, we're going to be applying it in that way. All right, so know that's where we're going with this.